So let's start it. So I show you how to program an NFT contract in 30 minutes with SmartPy. SmartPy is one of the most used language on Tezos. It's used by most of the top Tezos D app, and most of them are related to NFT. And we've worked a lot to improve the way to build NFT with SmartPy. So I want to answer two questions today. What's the minimal amount of code to deploy NFT, so from scratch to deploy NFT? And how easy is it to add the exotic features? So there will be 4 parts in this talk. An introduction on what is SmartPy. Then I'll code with you a basic contract. Then we'll do something a little fun, which I call the Dracula NFTs. And then we'll sum up what we've learned today. So SmartPy is a smart contract language. As I said earlier, it's available through a Python library. So you code things like this, and you can compile it to Microsoft code and deploy it on the Tezos blockchain. It has a complete set of tools. Web IDE, we'll use it today, but you can also use your own IDE with the command line interface. There is also a contract explorer, a simulation engine, and other stuff. I want to emphasize the importance of simulation engine because it permits to write a lot of tests without having to deal with the problems of the blockchain. So it's super fast, and you can write tons of tests. That's important because security is the most important thing for smart contracts, and testing is the best way to have a secure smart contract. Also, there are a lot of documentation, a reference manual, some guides, so commented code, and trainings. And also, you can find a lot of resources outside of the SmartPy website. So there is no way you can't learn SmartPy. So let's start by writing a simple NFT contract. So on Tezos, NFTs are built with the FA2 standard. So it's the standard that describes what is an NFT contract. NFT contract should have at least 3 entry points. The transfer entry points to transfer NFTs, balance off to get to know who owns what NFT, and update operator to give special permissions to some users. And FA2 is use similar entry point interface for all type of tokens. So if you are building NFTs or fungible assets or single assets, it will be always the same 3 entry points with a different logic. In the storage, I want to emphasize 2 things. The first one is the ledger. So for NFTs, it associates a token ID with an owner address. So in this example, Alice owns 2 tokens, the token with the token ID number 1 and the token ID number 4. And in the storage, you can also find the token metadata. So they associate a token ID with a token info. And the token info is a map with some info. So you can have key values. There are standard keys and values, but you can invent your own if you want. And you can put also empty key and give a link to a JSON file. For example, here we upload a file on IPFS, and we give the link in as the value. So it will give the name of the NFT, perhaps the image, the creator, and all sorts of things. That's what we are going to write now. So the first thing to do in SmartPy, as in all language, is to import it. So import SmartPy as SP. the second thing we'll do is to import the FA2 library. I hope can you see well the code? Yes? Oh, yeah. So with SmartPy, you can import codes from a URL. We'll do that and import the FA2 library. So I zoomed too much, and we can't see the link to the library, but yeah. So this library will help you to write an easy code with FA2. You can also find the whole code here in the regular template. So you have a lot of examples of contracts here with tests and comments. So do not hesitate to look at them. And the last thing we'll do is to create a class. So this class is your smart contract. Let's name it TezDev NFT. And we'll inherit from a base class given by the FA2 library called FA2 NFT. So if you are using a FA2 fungible, it will give you a fungible base class. And you can write pass, and you already have a good NFT contract. So I think it's finished, and I ended my talk. Yeah, so after one line of code, you have a basic NFT contract that can transfer, have balance off, and update operator. But there is no way to mint the NFTs, so you can't have NFTs inside it. So let's create one entry point for that. You are not bound to the base contracts, base entry points given. You can write your own. Can you hear me? Yeah. So we'll add this entry point later. But for now, let's simply compile our contract. On SmartPy, you can add a test with this decorator and a simple function. And inside it, you can do three things. The first one is to create a test scenario. So sp.test scenario. The second thing to do is to instantiate our contract. So TezDev NFT equal TezDev NFT. And it asks one parameter. It's the metadata. I'm not digging into the details, but I've already uploaded it on IPFS, and I'm giving the link here. So you can't read anything. OK. So I'm giving the URL. And the last thing to do is to add the contract to this the test scenario. And you can run. OK. Oh, yeah, I don't have access to the internet. For sure. Let me give it. Ah mince. Yeah, vas-y. Yes, sorry, sorry for that. OK. So let's run it again. OK. So now the contract is compiled. And we have a lot of details here, but it's really too big. But we have a lot of detail here. I'm not digging into the details. But I just want to show you that there is a ledger as expected. there is also the token metadata map I was talking about. And also last token ID, we'll use it really soon. And you can also read the code of your contract. So it contains everything needed. But for now, we'll add the mint entry point. So a mint entry point lets you create an NFT contract. So on SmartPy, you create an entry point with @sp.entryPoint. And you create a method like this. I will name it mint. Is it still big enough to read? A bit too much. Yes. So the mint entry point will have two parameters. The first one is the owner, the first owner of the token. And the second parameter is the token info. And what we have to do is 4 things. The first one is to get the token ID of this current token. So we can take it from the storage. We access the storage in SmartPy with self.data.something. Here we have the last token ID we can use. Then we want to insert into the ledger. So the ledger is in the storage, so self.data.ledger. And we want to access to the key token ID. So exactly like in Python, you would do to insert in a dictionary, you insert it in the map. And the value is the owner. And we'll do the same with the token metadata. With a subtle difference, I'll not explain because we don't have time for that, but there is a little things needed by the FA2 norm. And the last things to do is to increment the token ID for the next mint. And we can compile and see if I made a mistake somewhere. OK, so no mistake. So now we can test it and prove that the mint entry point works. So you see it's really simple. There is 4 lines of code for the mint entry point. And we can write a test. So the testing system is very powerful. We can get 2 addresses, create 2 addresses. There is also an internal system to create fake addresses. On this scenario, you can also print data. So I'll show the 2 addresses in this scenario. You can also write titles with so sc.h2 and write anything you want. So for example, here I will demonstrate mint. So I write a title called mint. And you can call the entry points of your contract. So here I'll call the mint entry point. And give the 2 parameters. Owner, it's equals to Alice. And token info, it's a map, as I said. And I'll give only one empty value, empty key, and the value will be a link to IPFS JSON with all the information inside it. And that's all. We can run the test and see if everything is OK. OK, so it should have worked. Let's show it. So here in the scenario, we can see that we printed the address of Alice and Bob. The title mint is here. And we have the transaction we've done. We can see the last token ID has been incremented because we can have a look at the storage of the contract. So it was 0, it's now 1. In the ledger, we have for the token ID 0, the Alice's address. And in the token metadata, we have the corresponding token info. You can also get the Michelson code equivalent to this transaction and play it on chain if you want. But now we want to test, because we visually tested everything's okay, but we can automate the tests by coding the scenario .verify, and we can access the data of the contract with .data, and we want to see if in the ledger for the key 0 we have Alice. So I press Control Enter and it will run perfectly. If I write Bob, there is an error for sure because we minted the token for Alice. So let's put back Alice. And we can also do a transfer. So the exact same way, we can write a title transfer and call TezDev NFT.transfer. And we give it expects a list of record with a from address. So from is Alice. And a transaction. So TXS equals a list of a record with Bob. So a record is equivalent to a structure. It generalizes the pair instruction of Michelson. This whole entry point interface is the same for all FA2 tokens. So here you can see it expects token ID and an amount. You can transfer an amount of 0 simply to test if everything's going well. And you can also try to transfer 2, but it will fail for sure. But it can work for fungible assets. And here we say that this transaction is done by Alice, because otherwise it would fail. And the exact same way we tested for the storage before, we'll do it here. But now we expect that the ledger has been updated. So Bob is the owner of the token. So let's run it. Yeah, so everything's OK. We have the mint, and then we have the transfer with all the information. And we can check that everything is OK. The last thing I want to demonstrate is that if you want to transfer it again from Alice to Bob, it will fail because Alice doesn't own it. So if you run again, you'll have the error message, FA2 insufficient balance. But you can say that you expect this code to fail with valid equal false and give the exception expected. And if the transaction is invalid with the right exception, the test will be OK. And here you can see the transfer failed as expected. So it's really powerful. Here we wrote a lot of tests with little code. It's something expected, in fact, if you are developing something you want to be really serious and secure. But I want to say that we also give a library for testing your FA2 contract. So in a few lines of code, you can run tons of tests, like really few lines I wrote there, and you have like 60 tens or something like that. So we now have a NFT contract. You see that it doesn't require a lot of lines of code, and we can now deploy it on the blockchain. So let's click on deploy. Let's choose GhostNet. I hope everything will work. Here we can choose the wallet, I'll use a faucet account. And yes, this interface is the same for every code you want to deploy using SmartPy. Again, you can do it with a command line interface. OK, so the contract originated successfully. You can wait for the block confirmations here. So there is one block confirmation. And you can open in the Explorer. And in the Explorer, you'll be able to interact with your contract. You'll be able to see the storage, the operations, and the code associated. Let's try to mint on the blockchain. So for the owner, I'll put the Alice's address. And for the token info, I'll give an empty map and the IPFS link. Let's build the transaction parameters. You can see here the parameters. You can still use the command line interface, and it will give you the command to run. But I'll use a wallet. Again, a faucet. Let's choose Alice and run. And call the contract. OK, so everything seems to be OK. Let's wait for block confirmation. If we don't see it, it will try again. Yeah, OK, so there is a block confirmation. So it seems to be OK. So we can see here on another Explorer that the transactions is OK. We have a mint. And if we click here, we can see that TezDev already saw our tokens. It's named Count Dracula, and we can see the image here. So it's the next slide I want to show you, because we finished developing this little simple NFT contract with a few lines of code. So is everything clear for now? Yes. So what I showed is that with really few lines of code with the FA2 library, you can do a really simple contract. But I want to do something a bit more exotic. And I came with this idea, NFTs that only exist at night. So I called it Dracula NFT, and we'll build that. So for Dracula NFT, we want the each tokens to be associated to a time zone. So it's the same storage as before. And in the token info here, we'll add the time zone. That's the only thing that will change in the storage. But the storage type is the same as before, because we can use the token info for that kind of info. And in terms of entry points, we don't have to change the mint entry points, because you give him the token info, so you simply give this time zone as a parameter. So the only entry points you want to change is the transfer, balance off, and update operators. And what we want to do is to read the time zone and fail if it's daytime. So there are two ways to do this. We could rewrite every entry point. To do that, we can use a functionality from Python. Here we can create a new entry point. And if we name it transfer, it will replace the transfer entry point. So we could do this, copy the transfer code of the original library and modify it to block if it's daytime. And do that for the 3 entry points. But it's strange because we want to keep the logic of the whole entry points. So the second way is to modify a method used by all the 3 entry points called isDefined, and it simply should return if the token is defined or not. So we will modify it and return it doesn't exist if it's daytime. So we are going to do it together. So let's redefine the isDefined method. So it takes a token ID and says yes if it exists or no if it doesn't. With sp.now, we can get the block time, so the timestamp when the transaction has been made. With minus timestamp 0, we can convert it to NAT number. We can then gather the time zone from the storage. So I'm doing something a bit complicated. I'm not explaining into details because I don't have enough time. And then we want to unpack it because it's converted to bytes. And we want to add the time zone to the current timestamp. And now we want to know which hour it is with a modulo operation, and if it's minus 6 a.m. And the only thing that we need to change here is in the meta data of the token info. We have to say that the time zone equals to pack of, for example, 0. If the time zone is 0, it's easier for tests right now, so I'll keep a time zone of 0, but it's important to have a test with other time zone. And we can compile again and see if everything's OK. So everything. So I don't know what mistake I made. Let's replace here. OK, so now we have a token that verifies the time zone. We can add, in fact, the mint here, the transfer here work because we haven't specified any timestamp that we want to simulate. So it considers it's January the 1st at the start of the day, so it's still night. So this transfer test works. But if we want to test at another time zone, we can test here. For example, what would happen if we want to transfer the token at night with these timestamps? And I forgot to copy these lines of code. OK. So now we are doing a transactions to Alice with an amount of 0 and the token ID 0. So we are not really transferring, simply testing if a transfer would have worked. And here we see a timestamp that is before the authorized moment. And the test works perfectly because there is an exception, FA2 token undefined. So now our tokens only work at night, and we achieved the goal of building a Dracula NFT. I want to add another feature is to have an administrator. we have a lot of mixins with the FA2 library. So mixins are a class you can inherit from, and that will add little functionalities. So for example, here we can inherit from FA2 admin. It will add an entry point, set administrator, and a method you can use everywhere in your code is administrator to know if someone is the administrator. We'll add an initialization in the constructor. So if you don't know Python, it's a standard way in Python to originate, to construct things when you have multiple inheritance. And we'll modify the mint entry point, so only the administrator can mint the tokens. The administrator can also be a smart contract. If you want to create a smart contract that gives the rules for minting, it's a good idea to create an administrator and say it's the smart contract. So we'll do these changes. Here, fa2.admin. Next, I'll copy the sorry, where is it? Yeah, I'll copy the constructor. In the mint entry point, we'll add a verification. So sp.verify self.isAdministrator. Now we can call it, because we inherited from this method, isAdministrator sp.sender. And if it fails, we want an error message to be not admin. Let me put that as at the beginning here. Okay. And now we have a mint entry point that is only bound to. Oh yeah, I made a mistake in the indent. So what's the problem? Yes. Okay, I copied this. Okay, I made a second mistake. What is the problem? Is it related to that? I don't know. Okay. Okay, I don't know. Oh, yeah. And now we need to give the admin when we originate the contract. So here, at the origination time, I'll give the admin. I say it's Alice, so we can run the other test with the mint admin. Oh, what's the, oh. Maybe you need to define Alice before. Yeah, sorry. Right. Okay, so I don't know where I made the mistake, but okay, so now we know that only Alice can mint the tokens, and we have seen that with 4 lines of code and a simple method, we have added 2 interstring functionalities to our contracts. So what we saw today is that writing a basic NFT contract using the SmartPy FA2 library is really easy. We've seen how to add a mint entry point. We wrote a test scenario. We originated a contract, and it's working, and it's already working on the chain. We customized the entry points logic and added an administrator with an admin mixin. there are also a lot of other things we can do with this library. There are a lot of more mixins to add a burn entry point, to add a default mint entry point without the functionality we wrote today. We saw, in fact, the default mint entry point is exactly similar to the one we wrote, but it would be it's more fun to write it from scratch for today. We can add by default off-chain views, on-chain views, etc. We also generate the contract's metadata, so you don't have to generate it from the off-chain views. You can write off-chain views exactly the same way you would write entry points, except that you give a off-chain view decorator, and it will be added to the metadata. We have the test library I talked earlier with 60 more tests. We have 2 other base classes to do the same thing with fungible tokens and single assets. And one important feature is the policies. So policies let you change a little bit of the logic of your contract without interfering into the entry points, a bit like we did with the isDefined, but with the transfer policies. So you can have the no transfer if you want tokens not being transferable. For example, if they represent permission. You can set the owner transfer, so only the owner can transfer the token. Owner or operator transfer, so operator can also transfer. Post-transfer can take another policies and apply to it another logic, which is that the administrator can pause the contract, so you need to define an administrator. And then if it's paused, you can't transfer any more tokens, and you can write your own policies. So we could have implemented the Dracula NFT with policies, but it was simpler to do it with the isDefined method. So thank you for this, for your attention, and I hope you've learned things today, and you'll like SmartPy. So do not hesitate to go to smartpy.io. Also, we are really active on Telegram, so do not hesitate to join. If you have one question, it's the good place to ask, and see if you have question. I can take some. Yeah. Yeah.
And just to let everyone know, we only have time for one question, so we'll have everyone go up after.
Thank you very much. Thank you for the presentation, Vincent. I have a question regarding the test capabilities of SmartPy.
Yes.
Usually, in the regular development cycles, it's often seen as a good practice to build as many tests as were function, unit tests, namely. While here, everything was in a big test. Does it correspond to a SmartPy specific good practice, or was it just for convenience?
Yeah, so if you use the test library, it will create a lot of different tests. So there is no all in one test, but it's simpler for a lot of things to have a large scenario to be sure you can run from beginning to the end. But it's also a good idea to split a lot more in and have very specific tests. Yes.
That was a quick one, so we'll do one more.
Hello, thank you very much for the presentation. The first question is, I didn't see where did you initialize the storage in the smart contract?
Yeah.
And the second question is, sometime I'm going through Better Call Dev or TZK, and I'm seeing the smart contract in Michelson. So SmartPy compiles down to Michelson. Is there a way to decompile Michelson to SmartPy to see? To see?
So for the first thing, yes. So here we in the code we haven't initialized the storage. That's a good remark because it's we gave everything to the FA2 library, and he has done everything. The only thing we can do here, yes, we can give more values here, and it will add it to the storage. But we can call also update initial storage to update the values and replace the values if we don't want the FA2 library to the value given by the FA2 library. Also, the third things we can do.
Where does the last token ID comes from?
Yeah, so it comes from the call to the init of the FA2 library because it gives, yes. The last things I want to say is that also it contains a capability for pre-minted tokens. So it's described in the documentation, but you can also give arguments that are not the exact storage, but the info needed to create the storage. Because it does some computation in between. So there are multiple ways to set it, and you can do everything you need. And for the decompiler, yes, there is a possibility, but it's not released yet. But we are working on it. It's already working, but it's still experimental. But yeah, you can use a decompiler with SmartPy.
So just to come back to the first question, the storage initialization is delegated to the class FA2, basically.
Yeah, but you can take hand on it if you want. If you don't want to call the initialization, you can do it by yourself, or you can replace value by value the things you want. So you can customize everything you want.
Okay, thank you.
With that, let's give a big round of applause for the live coding session.